Now we're going to talk about buffers. In chemistry, a buffer is a solution that resists pH changes. And these are kind of cool. So what a buffer is it's a solution that has significant amounts both of the weak acid, and its conjugate base. So if base is added to this solution, the weak acid can neutralize the base. And if acid is added, the conjugate base can neutralize that because they're both present. And we'll look at, some equations and stuff. But your blood is a buffer. Your body buffers your blood so that your pH is between 7.36 and 7.40 in pH. And if it gets outside of that, you're in big trouble with your health. So if it goes below 7 or goes above 7.8, you're going to die. So you've got buffers going on in your blood, and it works really, really well. So here's an example of a buffer system. Acetic acid with sodium acetate. So acetic acid is not one of those 6 acids we learned about as being a strong acid. Acetic acid is a weak acid, meaning it does not dissolve or dissociate completely into ions. In fact, most of it is present as the molecule. So in this acetic acid sodium acetate buffer system, if we add sodium hydroxide, the acetic acid that is present will react with it and neutralize it, forming water and sodium acetate. There is also sodium acetate present, and if we add an acid to that, this acts as a base and forms acetic acid and sodium chloride. So whichever way, if you add acid or if you add base, you have a component there that can neutralize it. So here's a picture. Pictures are good. So what do we have here? So this is the acetic acid, and this one, and this one, and this is the sodium acetate in the blue. Sodium acetate is an ionic compound. It's very soluble in water, and it dissociates completely. So we've got sodium ions and acetate ions. These acetate ions do not come from us adding acetic acid to the solution. You add acetic acid, and that gives you the acetic acid molecules, and you also add sodium acetate. And so you want to have roughly equal portions. So if we add acid to this, so here's the acid in red, the hydrogen ion. The hydrogen ion can react with the conjugate base, the acetate, and form acetic acid. And that neutralizes the base and causes the pH to change very little, if at all. If we add hydroxide, a base, the hydroxide will react with this weak acid and take its hydrogen ion, and it'll form acetate ion. But in both of these situations, we do not have any hydrogen ion or hydroxide ion being formed extra in the solution. Let's go back here. So the base reacting with the acid, we've got water, which is neutral, and this sodium acetate, which is just going to form acetate ions. And here we add the acid, and the sodium acetate reacts with that, and we get acetic acid and sodium chloride. If you add sodium hydroxide to pure water, you get a lot of hydroxide ions. If you add hydrochloric acid to pure water, you get a lot of hydrogen ions, and the pH changes. When you have a buffer system and you add acid or base, the pH does not change much at all. The buffer can only handle so much of that. If you add more, you'll overwhelm the buffer, but it will take moderate amounts. So what do you need to know about this? I think the only question that'll be asked is something like, I'll give you two an acid, well, two species, and say, is this a buffer system? How do you identify if it's a buffer system? Well, it needs to have an acid and its conjugate base. And there should be examples in the slides here. There are not, so I'll make some up. Okay, so what if we had HCl and sodium chloride? Is that a buffer system? What is a buffer system? It's a weak acid and the salt of the conjugate base. So this HCl is an acid, right? And this is a salt of its conjugate base, but is HCl a weak acid? No, HCl is a strong acid. So this is not a buffer. Think of something. What if we had HF and potassium fluoride? Is that a buffer system? Well, first ask, is HF a weak acid? Yes, it is. It's a weak acid. Is this the salt of its conjugate base? What does HF do? Don't have enough room here. When it reacts with water, it forms fluoride ion and hydronium ion. This is the acid, this is the conjugate base. So is KF the salt of the conjugate base? Yeah. It's an ionic compound containing the conjugate base. The relationship between these two is that we've taken the hydrogen off and exchanged it for a metal. Do you see that? With the sodium acetate, we did the same thing. So we had acetic acid and sodium acetate. The only difference here is this one has an H and this one has a sodium ion. You see that? In the HF and the KF, one has the hydrogen ion, one has a metal ion. And the HF is a weak acid, and so that one is a buffer. Oops, this is a buffer. So this one's a buffer, and this one's a buffer. This is not a huge deal. I think there's probably only one question on the final going to be on this. So if this is just like making your brain hurt, I give you permission to ignore it. You can still pass the class. But if you're looking for that A, you should know how to do this one. Any questions? So, chapter and review. Those are the things we've talked about. Chemical skills, that doesn't fit in there very well, does it? There we go, that's better. So you should be able to identify Bronsted-Lowry acids and bases and their conjugates. You should be able to write equations for neutralization reactions. You should be able to write equations for reactions of acids with metals and with metal oxides. You should be able to do acid-base titration problems, like you're going to do in lab today. You should be able to determine the hydronium or hydroxide ion concentration of solution. If you're given one of them, you should be able to find the other from the KW. And then you should be able to calculate pH, pOH. And the hydronium and hydroxide ion concentrations. End of chapter.